Hello students, in this video we'll introduce the notion of a u-substitution. If we recall from Calc 1, the chain rule states that the derivative with respect to x of the composition of two functions of f composed with g of x is equal to f prime, the derivative of the outer function, evaluated at the inner function, times the derivative of the inner function. What we can do now is we can take the chain rule and the fundamental theorem of calculus, combine them to get what's known as u-substitution. So in particular, if I integrate from a to b of this function over here of f prime of g of x times g prime of x dx, by this chain rule identity, we know this is the same thing as the integral from a to b of d by dx of f of g of x dx. And now when you integrate a derivative, you just evaluate the innermost function at the endpoints. So this will be f of g of b minus f of g of a. What this is this is equivalent to the integral from g of a to g of b of d by du of f of u du, where I've simply just switched the variables. So we get the following relationship for u-substitutions. We get that the integral from a to b of f prime of g of x, g prime of x dx is the integral from g of a to g of b of f prime of u du, and we call this a u-substitution. So what's happening over here is if we have an integral that looks like this, what we do is we make a u-substitution key. What's happening over here is playing the role of my u is g of x. Playing the role of my du is g prime of x dx. And that makes sense too, because if u is g of x, then du dx is g prime of x. So all I'm doing is I'm just rearranging this in differential form to get my u-substitution. And then when x is equal to a, that says that u is equal to g of a. When x is equal to b, that says that u is equal to g of b. So this is how we handle the limits of integration. So every part of this formula has a partner on the other side of the equation. That is what we call a u-substitution. This is what we'll refer to as the key to the substitution. So in principle, this is how it works. Let me show you an example of this. If I want to find the integral from 1 to 2 of 2x e to the x squared dx, I would make a u-substitution. What we would do is we would make our key. We would let u be x squared. Then du will be the derivative of this. So the derivative of x squared is 2x. I put a dx over here. And then when x is equal to 1, that says that u is equal to, well, x is 1, u is also going to be 1. When x is equal to 2, that says that u is going to be 4. So there is our u-substitution key. And now we can write this integral in terms of u's using this formula. This is going to be the integral from 1 to 4. Then I have a 2x dx. 2x dx is the same as du. So those two terms over here are exactly just du. And then I have e to the x squared. That turns into e to the what? Well, x squared is the same thing as u. So this is going to be an e to the u du. And with my u-substitution key, I've changed my integral into an integral of a standard form. Now I know the antiderivative of e to the u is just going to be e to the u, evaluated from u equals 1 to u equals 4. So this will be equal to e to the 4th minus e to the 1, and that is your answer by the substitution. Thank you very much.